Hi everyone. We're going to wrap up the first part of chapter 9 with some applications and models of what we've been learning, or basically word problems. So let's start off by talking about angles in word problems. And there's two vocab phrases that go together. The more common one is angle of elevation. And an angle of elevation is an angle up, that's what elevate means, up, from a horizontal line. That's very, very important. Angle of elevation is always measured from a perfectly horizontal line. So even if in the question, let's say a person is standing on a hill and it says you're standing on a 20-degree slope or something, if it's measuring the elevation, it's not the angle of elevation, it's not from that 20 degree, it has to be measured from a perfectly horizontal line. Now the one that goes with it that isn't used quite as often is the angle of depression. And it's the exact same thing, but it's measured down from a horizontal line. So maybe if, in one picture or in one problem you're standing on the ground looking up at something, they might call that the angle of elevation. And in another question, maybe you're standing on the top of a building looking down at something, that might be the angle of depression. And I want you guys to notice, based on something you learned back in Math 4, these are actually the same thing. They are what you learned were called alternate interior angles. So let's say I had some sort of picture. I'm not even going to make it very specific. Let's say there's something up here and something over here. And there's some sort of connection from the top of from the point on the ground to the top of that building or whatever it is. If I ask you to measure the angle of elevation from the bottom, that would be this angle theta right here. Now, if I ask you to measure the angle of depression, here's the common mistake, is people go, okay, well that's this angle right here. That's the angle of depression because it's the angle down. But see, that's not measured from a horizontal line. That's not the angle of depression. The angle of depression would be if I imagined this horizontal line here and measured this angle here. Now, the horizontal line on bottom and the horizontal line on top are parallel because they are both horizontal lines. So the yellow angle and the blue angle are what we called back in Math 4 alternate interior angles, and they're congruent, they're equal. So they're actually both the same thing. So the angle of elevation and the angle of depression are the exact same angle. It just depends on kind of the wording of the question. Like usually it's where the person is standing. If the person's standing on the ground, we call it an angle of elevation. If the person's standing on the top of the building, we call it the angle of depression. But it doesn't really matter. It's the same thing. So here's an example. It says a wire is connected from the top of a 25-foot flagpole to a point on the ground 18 feet away. What is the angle of elevation of the wire? So let me draw a picture here. All right, there's my flagpole. It's 25 feet tall. A wire is connected from the top of it to a point on the ground 18 feet away. So let's say this is my point on the ground 18 feet away, and this, oops, I kind of missed. This is the wire. Okay, now, the right angle in this question is the flagpole. And remember, one of the things I mentioned this earlier in the year, we always assume right angles in a word problem. If it's a flagpole or a tree or a person standing, unless it says otherwise in the question, assume the ground is perfectly flat and assume whatever that thing is perfectly vertical. So that's your right angle. So we are asked to find the angle of elevation of the wire. That would be that angle right there. From the ground, the angle from the horizontal ground, the angle up to the flag. So let's start solving this. Let's look at our inverse trig here. Let's start off with just trig, with SOHCAHTOA, because this is a right triangle question. So because the right angle is down there on the ground, the wire is the hypotenuse. Because we labeled theta as the bottom right, that makes the 25 opposite and the 18 adjacent. So if I'm thinking about SOHCAHTOA for this question, the only two that are relevant, I don't know the length of the wire. It didn't tell me that in the question, so I can't use hypotenuse. I have to use opposite and adjacent. And from SOHCAHTOA, opposite and adjacent means I have to use tangent. See, I can't use sine because I don't know hypotenuse, and I can't use cosine because I don't know hypotenuse. So it almost always works out this way. There's only one that works. You pick the one that works, it's tangent. After tangent comes the angle. Now in this case, the angle is theta. And tangent of theta equals opposite over adjacent. For my picture, that would be 25 over 18. Now in the very last day of notes, we talked about the relationship between trig functions and inverses. So I have tangent of theta. I want to get that theta out of that tangent function. And I said one thing you can do is you can always change a trig function into its inverse. So I can change this tangent into an inverse tangent by just flipping these two numbers. So what I get is inverse tangent of 25 over 18 equals theta. Well, that's the actual answer to the question. All you have to do is type it into your calculator. Now for my calculator work, I'm going to go ahead and put my calculator in degree mode because for a word problem, we probably don't want radians. So I'm going to put my calculator in degree mode, and I'm going to type inverse tangent of 25 over 18. And it comes out to about 54.2 degrees. And that's our answer. That's our theta there. It's a 54.2 degree angle about. But the idea was read the question and set up the picture first. Use SOHCAHTOA to set up the question. And what changed from the first time we did SOHCAHTOA was this step right here. You know, once you get it set up, realizing I can't just type this into my calculator. The first time we did SOHCAHTOA, it always said like tangent of 21 degrees equals, and the x was over in the fraction to solve for. That's not the case anymore. When you're doing your trig function of an angle, and the angle is the variable, you know you're going to have to use inverses to answer that question. All right, we're going to switch gears. The other thing I want to talk to you about is something called bearing, which is very common in a trig word problem. And bearing basically means direction. So if you're talking about any kind of map question, you know, a boat or a plane or a car or just a person hiking in the woods, any kind of map question, you can use bearing to describe direction. Now what bearing does is it gives a direction in terms of north, south, east, or west. So I mean, it's great when you're traveling due north or directly north. The word due means directly. But what if you're not? You know, what if you're going somewhere between north and east? You can say northeast, but where? That's a big area. You know, how do I know the exact direction? I can tell you it's between north and east, but I want to give an exact direction. So if you're going to use bearing, one way to do it, and this is the way our book does it, is something like this. You see one direction, N for north, you see an angle, and then you see a second direction, E for east. This is how it works. This is where your angle starts. So when you see the north for the first letter, that means the initial side of your angle is basically right here, due north. Then this tells you where the angle ends, the two together. So you're going 30 degrees, because from north you can go two directions. You can go to the east or you can go to the west. So you can't just put an angle in there. You can't just say 30 degrees from north. You have to say 30 degrees towards east. And that's where this angle comes from. I went 30 degrees, that's this right here, but I went to the east side, not to the west side. And that gives you a bearing. So what you would do, the way you would say that in words is you would say, it kind of reads backwards. You say 30 degrees east of north. But I want you to know, like when you see it in the homework, you'll know what it means. It's always two directions. They have to be next to each other. You can't have like 30 degrees south of north. That doesn't make sense. But 30 degrees east of north, if it said 30 degrees, if that last letter was a W instead of an E, the angle would be 30 degrees on this side of north. So basically that's a way of giving any direction in terms of like a map, north, south, east, and west. So let's do a bearing question. That'll wrap it up for today. Here's our example. We have a ship leaving port, and that's what I said is very common for bearing. It's like a boat in the water. Ship leaves port, travels 20 miles due west. It then changes course and travels 8 miles due north. And remember, the word due means directly. That's perfectly horizontal and vertical distance. What is the ship's current distance and bearing from port? So let's draw a picture. Let's see what this looks like. We're going to be mostly in the second quadrant, I think. So let's say the ship started right here, and it traveled 20 miles due west. That would be directly to the left. So there's your 20. It then makes a sharp right turn, basically, and travels 8 miles due north. So that's where the ship is right now. It started at the origin. We can start it wherever we want. We started it at the origin. It went 20 miles west, sharp right turn, 8 miles north. So the question says, what is the ship's current distance and bearing from port? So what we're saying is, if I measure the direct distance from port where we started, what is the distance? That would be x. And what is the bearing? That would be this angle right here. We'll call it theta. So we have two separate questions. Number one is solve for x, and number two is solve for theta. Let's do them one at a time. I'm going to do the x part first. X is just Pythagorean theorem, just a very simple, straightforward a squared plus b squared equals c squared. And x is the hypotenuse. A and b are the legs, so I'll put the 8 here and the 20 here. So we have 64 plus, that would be 400. So 464. We'll take a square root, and I'm going to go ahead and use a calculator and approximate this. It's about 21.5, 21.54 maybe. We'll just call it about 21.5 miles. So x is about 21.5 miles. So the ship traveled a total of 28 miles. It traveled 20 miles this way, 8 miles up. But if you're measuring straight line distance now, it's about 21.5 miles away. Now for the second part of this question, let's find theta. Now for theta, I'm going to be a little bit more careful. The right angle in my problem is here. That's where you turned directly right, from west to north. That makes the x the hypotenuse. If theta is in the bottom right, that makes the 8 opposite and the 20 adjacent. And it's going to look a lot like our last question. It's going to be tangent again, because I want to use opposite and adjacent. I could use hypotenuse actually, now that I know it's 21.5. But one thing, you guys, a good thing for you to remember, anytime a number is given in the question, try to use that number. If I use my value for x, remember I rounded it off. It wasn't actually 21.5, it was 21.54 something, kept going. If you use a rounded off answer, your answer will be off by a little bit. So it's best to try and use the exact number from the question if you can. If you have to, do it. But for this one, I'm going to use the 8 and the 20. So I'm going to set up a problem for tangent. And it's going to be tangent of theta again. And this time opposite is 8 and adjacent is 20. So tangent theta equals opposite over adjacent. And I'm going to do the exact same thing I did in the last question. I'm going to say let's switch this to an inverse tangent by flipping these two numbers. So I have inverse tangent of 8 over 20 equals theta. And let's see what that is on our calculator. So I do inverse tangent of 8 over 20. 8 over 20 reduces. I'm not even going to bother reducing it because I'm typing it in a calculator anyways. It's about 21.8 degrees. Now, before you box that up, we need direction. We need bearing. So we don't want to just say 21.8 degrees. We want to give the letters too, the north, south, east, west. So for my final answer over here for theta, I'm going to say, if I'm measuring that angle, I'm going to start directly west because I want this to be where my angle starts. Then I'm going to put the angle, which was 21.8 degrees. And that 21.8 is going, from there it's going up, it's going towards north. And those two things together are my answers. So the first part I think was pretty easy, just Pythagorean theorem to find the distance. The second part, we had to use inverse trig to find the angle, and then the third aspect to that question is, remember, don't just tell me the angle is 21.8 degrees, that's not enough information. You got to tell me 21.8 degrees from where towards where. And we ended up with 21.8 degrees north of west. Starting from directly west, we're going at a 21.8 degree angle to the north of there.